Thank you, Xin. Any questions?
Hi, thanks for the great talk. I hope I'm audible. So you mentioned a slide where you might have already mentioned this, but you said that it's a challenge distinguishing dual AGNs from lensed AGNs. So I'm curious what fraction of the dual AGNs turned out to be lensed AGNs, and how does that evolve with Redshift?
Yeah, that's a great question. So the apparent fraction that we've been finding in our sample is roughly half and half, actually. So it's almost like a conspiracy. But obviously, so the apparent fraction is subject to a lot of selection biases. So we because of our emphasis primarily in the sample selection, so we are heavily biased against the low redshift system. So here on this bottom plot, you can see, so the field circles are, these HST, the Hubble resolved doubles and multiple sources from our sample, and they are not all dual or lens quasars. So some of them are actually interlopers from star quasar superposition. So this is already an outdated plot, but we have more of these systems, and we currently have 2 surveys programs with Hubble and JWST each, and they are primarily targeted on the so-called cosmic noon epoch, so around redshift 2 and 3H. Yeah, so as new results are coming out from these new surveys, we'll have a better understanding of the statistics.
Any more questions?
Hello, can you please say, you mentioned at one point you merged SDSS and DCAM data for, I presume, AGNs. And like, how did you do it? How many? And what's your, let's say, do you have code available? And is this upcoming? Any more details, please?
Yeah, absolutely. So for this particular study, we combined the SDSS archival light curves with dark energy survey light curves, but also our new DECAM light curves. So this is for a sample of total of a few thousand quasars. So the overall parent sample size is roughly a few thousand, but in this initial pilot study, so we will only have a less than 1,000 quasars to begin with. So now the sample size is much larger with our dedicated programs. So we actually released all the light curves, so I can send you pointers, and we also have the first DECAM light curve data release paper just coming out earlier this year. So we also plan to release more light curves from our long-term DECAM programs going forward. But yes, so you do need to be careful when you combine the light curve from these different surveys. So and I can point you to more of these technical details.
Thank you. Okay, maybe time for one more quick question where we set up the next speaker.
I'm gonna stop sharing your screen.
Okay, Xin, I have a quick question for you, which is related to this last topic. So I'm wondering, with the long baseline DCAM data, how many more of these candidates do you expect to find? I mean, obviously, that will give you a longer baseline. Maybe you can find larger separation objects, but also have better photometry for a longer baseline. So maybe you can also find more of the shorter separation binaries. What is your expectation?
Yeah, absolutely. So the number, like I'm sure this is order of magnitude uncertainty here, but the ballpark number is ranging from a few tens to maybe a few hundreds of these type of candidates. And with a much larger sample size, as you increase the sensitivity with LST, you're gonna be able to detect these even rarer gems with, even a smaller residence time, right? So these are expected to be rare and only be able to discover them with a much larger sample. And and eventually you may be able to actually trace the orbital decay of these binaries. So there are papers done by Zoltan Hyman and his students, and there are also several other groups working on predicting these populations.
Yeah, great, thank you.